In this video, we're going to find the cube roots of a complex number, but what we're going to do is we're actually going to use DeMoivre's theorem to help us find these cube roots. And to find the cube roots of this complex number, we're going to set up an equation. And we're going to make that equation, or we're going to let that equation be that z cubed is equal to 4 times the square root of 3 plus 4i. And to find the cube root of 4 square root of 3 plus 4i, we take the 1/3 power, or we raise both sides of this equation to the 1/3 power. And when we raise both sides to the 1/3 power, we'll have z is equal to 4 square roots of 3 plus 4i raised to the 1/3 power. And to solve this now, we're going to use DeMoivre's theorem, just like we did in our previous example. So let's first take this from rectangular form, or a plus bi form, and let's put it in polar form. So let's find our r and our theta. R is equal to the square root of a squared, which is 4 square roots of 3 squared, plus b squared, which is 4 squared. So that's the square root of 16 times 3, which is 48, plus 4 squared is 16. 48 plus 16 is 64. So we have the square root of 64, which is 8. So our r value, or our modulus, is 8. Now let's find our theta using tangent of theta equals b over a. Well, that'll be 4 over 4 square roots of 3. Of course, the 4's will divide out, leaving us with 1 over square root of 3. Now there are two thetas that satisfy this equation. The tangent of theta is positive in the first quadrant and the third quadrant, so we need a first quadrant solution and a third quadrant solution. Well, the theta that has a tangent value of 1 over root 3 in the first quadrant is pi over 6, and in the third quadrant, it will be 7 pi over 6. But now we have to make a determination of which one of these that we can use. To make that determination, we come back over here to our original complex number. A positive a and a positive b lands us in the first quadrant, which means that we have to use pi over 6, not 7 pi over 6. So this complex number, when written in polar form, is z equals 8 times cosine pi over 6 plus I sine pi over 6. And we know that the solutions to our original equation here can be found by raising that to the 1/3 power. To find the first solution using DeMoivre's theorem, we take the modulus 8 and raise it to the 1/3 power. Well, that's the same thing as the cube root of 8. The cube root of 8 is 2. And then we know, again, using DeMoivre's theorem, that we have to multiply the argument by the exponent of 1/3. So we'll be multiplying pi over 6 by 1/3, which will give us pi over 18. So our first solution is 2 times the cosine of pi over 18 plus I sine of pi over 18. And because we're finding cube roots, we know there are going to be 3 solutions. And we know those 3 solutions have to be evenly spaced around a circle from 0 to 2 pi. So that means that each one of them will be 120 degrees apart from the other. 120 degrees in radians is 2 pi over 3 radians. So I need to add 2 pi over 3 radians to my argument of pi over 18 to find the location of my next solution. 2 pi over 3 radians is the same thing as 12 pi over 18 radians. Pi over 18 radians plus 12 pi over 18 radians gives me 13 pi over 18 radians. So that's where the location of my second solution will be. So z sub 2, our second solution, will be cosine 13 pi over 18 plus I sine 13 pi over 18. And then to get our third and final solution, again, we'll add 12 pi over 18 to 13 pi over 18 this time to get 25 pi over 18. So our third solution is 2 times cosine 25 pi over 18 plus I sine of 25 pi over 18 is our third solution.